In this video, we're going to first look at two sample proportions. In testing a two sample proportion, it's very similar, the hypothesis part of it anyway, to the two sample mean test that we looked at last time. You do want to use a z-test if they are considered independent. Now, I'm not going to go through and compare all of them, but I'll do one. If I said something like the percentage of female, let's do P of F just for female doctors, compared to the percentage of male doctors. If I just compared those and I said, I believe there are more female doctors than male doctors, that would mean a greater than symbol. And you do exactly what you were doing before. Now, if this is sample 1, this is sample 2, you would move the P2 over to the other side. That, of course, would be the alternative. So you get P1 minus P2 is greater than 0, which means that the null would be that P1 minus P2 is less than or equal to 0. Likewise, you can have hypotheses of P1 minus P2 that is greater than or equal to 0 with the corresponding alternative P1 minus P2 less than 0. And of course, P1 minus P2 is equal to 0, and P1 minus P2 is not equal to 0. Same hypotheses. We're not going to reinvent the wheel. Those are exactly the same when you're comparing two proportions. It's identical to comparing two means. The formula that is used for the z-test for two proportions is z equals p hat 1 minus p hat 2 minus p1 minus p2 all over the square root of p bar times q bar times 1 over n sub 1 plus 1 over n sub 2. Because it's a z-test, I know that the table that's going to be used is the normal distribution. And this is the hypothesis parameter that needs to be in our hypothesis. Some of those pieces need to be calculated. So p hat 1 is x sub 1 over n sub 1. P hat 2 would be x sub 2 over n sub 2. X is still the number of successes, n's are still sample sizes. And p bar. P bar is x sub 1 plus x sub 2 over n sub 1 plus n sub 2. And of course, p bar plus q bar equal 1. All right, with all of the formulas down, we don't do anything different. So let's start. This first test, it's going to take us longer to collect the information or to write down everything. Let's see, it says a study was conducted to compare the proportion of smokers that are under 20 to the proportion of middle-aged smokers. So we have under 20 and middle age. These are the proportion of people that we have. So it says here, a sample of 200 people under 20 had 56 smokers. So that's our X. Now this is the first sample being mentioned, so I'm going to put the ones on it. A sample of 175 people between the ages of 35 and 50. I guess that's middle age, so I'm old. Had 55 smokers. Is there a lower proportion in the younger group? Test at a 0.01 level. Okay, so we have an alpha of 0.01. Well, proportion 1, proportion 2. Is the proportion lower in the younger group? Here's the hypothesis. So I'm going to build my test over here. H sub 0, H sub 1, critical value, obtained value, in conclusion. Now, that's going to definitely be an alternative. So that's P1 minus P2 is less than 0. which means that my null will be P1 minus P2 is greater than or equal to 0. It's a z-test, so it's a normal distribution, and it happens to be a lower tail on this one. To find that z-score, we take our alpha, 0.01. I find the area from 0 to this point, 49. I've done that one before, and because it's on the left, I'll call it negative, so negative 2.33. I need to calculate a few values, so let's do that next. I need p hat 1. That's 56 over 200, which is going to give me 0.28. P hat 2, which will be 55 over 175, which is 0.314. We need p bar. That's 56 plus 55 over 200 plus 175, which gives me 296. I'm also going to need to know what q bar is. So 1 minus 0.296 is 0.704. Let's plug into our formula for our obtained value. Z is equal to 0.28 minus 0.314. P1 minus P2 is still 0. Let me write that better. Minus 0 all over the square root of 0.296 times 0.704 times 1 over 200 plus 1 over 175. After you put that into the calculator, you do get negative 0.719. That is negative 0.719. That actually falls here, which means we're going to accept the hypothesis. So let's see. I'm going to accept this guy. So I'm going to move the p sub 2 over to the other side, and I get P1 is greater than or equal to P2. So the percentage of smokers in the younger group is larger or equal to the percentage of smokers in the middle age group. Or you can say the proportion of younger smokers least that of middle age smokers. All right, let's look at our second example. This one says a study was done comparing Oh, it's on 2 different pages. Okay. Okay, well, hopefully it's written correctly on yours. I'm going to scoot down and I'll read it from my page, and you've got it also. It says, a study was done comparing recycling done in large cities compared to smaller towns. So we have large cities and small towns. It says, and these are with a population over 250 versus small. Okay, so 250 in a city with a population over 250,000, I guess they consider that large, 250 people were interviewed. And 115 of them said that they did some type of recycling. In the small towns that were under 775,000, 120 people were asked, and of those, 41 did some type of recycling. Is there a difference in the proportions at a 0.05 level? All right, is there a difference? Okay, so P1, P2, is there a difference? That means, are they not equal? So I can go ahead and build my hypothesis test. Here's the null, the alternative, the critical value, the obtained value, and the conclusion. That's going to give me P1 minus P2 is not equal to 0. My null will be that P1 minus P2 is equal to 0. I know proportions tests are normal tests. This one is a two-tailed test. Because it's a two-tailed test, I'll need a plus or minus. My alpha is 0.05, so I will put 0.025 in each half. I know that this then is 0.475. I can look that up in the body of the table. I get 1.96 and negative 1.96. For the obtained value, I've got to do some calculations. I did them ahead of time because I don't have a lot of room. P hat 1 is equal to 0.46. P hat 2 is equal to 0.342. P bar, when I plugged into that formula, was 0.422. And because I know that P bar and Q bar equal 1, that gives me a 0.578 as my Q bar. So let's plug into our formula for our obtained value. 0.46 minus 0.342 minus 0. All over the square root of 0.422 times 0.578 times 1 over 250 plus 1 over 120. We'll plug that into our calculator, and we're going to get 2.151. That falls over here somewhere. Because it fell in the shaded region, we're going to reject the hypothesis. Because we reject the null hypothesis, that means we accept this one. So to write my conclusion, I'm going to move the p sub 2 back over to the other side, and it's going to say the proportion of people who recycle in larger cities is not equal to the proportion of people who recycle in small towns. Wow, that's a long sentence to get all the information in it. All right, I'll see you in the next video.